Good morning, students. Let me introduce myself. I am Mehaboob. I am dealing with the subject chemistry, and hope you are all safe in your home. Today we are dealing with the new subject, new topic, that is acids, bases, and salts. Acids, bases, and salt. In our daily life, we come across many substances. Some of them are sour in taste. For example, lemon juice, tomato, vinegar, then tamarind, etc. All they are sour in taste. And some substances which are bitter in taste. For example, milk of magnesia, then slaked lime, etc. They are bitter in taste. And there are some other substances which cannot be identified by their taste, isn't it? So the substances which are sour in taste are acidic in nature. The substances which are sour in taste are acidic in nature. The acidic nature of this is due to the presence of a particular acid in that type of substances. For example, vinegar. See, vinegar, the acid that is present in vinegar is acetic acid, and the acid that is present in tamarind, that is tartaric acid. Tartaric acid. And then tomato, that is oxalic acid. And in lemon juice, citric acid. So a number of examples are there. All these substances, they are sour in taste due to the presence of a particular acid in that particular substances. And all these acids they are organic acids. They are organic acids, they are natural acids. And then there are some other, in addition to this organic acid, some inorganic acids also present. These are natural acids because they are present in nature, and in addition to this there are some inorganic acids, or otherwise they are called mineral acids. Mineral acids. Mineral acids examples: hydrochloric acid, sulfuric acid, nitric acid, etc. All these acids are prepared in laboratory, or we can artificially prepare these acids, and they are present in labs for various experiments, for conducting various experiments. So these are all mineral acids. So these acids, that is, whether it is natural acid or mineral acids, they are sour in taste due to the presence of a particular acid in that particular substance. Now, there are certain other substances which are bitter in taste, and soapy. It feels soapy when we are touching that substance. They are called bases. The substances which are bitter in taste and soapy to touch, that is called bases. And bases, or otherwise we call them as alkali. And this base and alkali, there some difference are there, that we will discuss later, because all alkalis are bases, but all bases are not alkalis. That we will discuss later. So bases, or otherwise they are called alkalis. And example, sodium hydroxide is a base, potassium hydroxide, then calcium hydroxide, aluminum hydroxide, magnesium hydroxide, ammonium hydroxide, many other. All these are alkalis. They are bitter in taste and soapy to touch. And these are called bases. Then there are certain other substances which are formed by the combination of acids and bases. There are certain substances which are formed by the combination of acids and bases. They are called salt. They are called salts. And the reaction between acids and bases that you have already studied in your lower classes, they are called a neutralization reaction. It is called a neutralization reaction. Neutralization reaction. For example, the formation of NaCl that you have studied in lower classes, when sodium hydroxide react with the hydrochloric acid, it forms sodium chloride plus water. That is when acid and a base, when a base and acid react, it forms salt plus water. That reaction is called a neutralization reaction. So this is the general introduction about the acids, bases and salts. And see, these acids and bases, their reactions are they are opposite to each other, and that is why they neutralize. They are opposite in action, and that's why they neutralize us. Acids and bases, when they are undergoing any type of chemical reaction, they undergo neutralization reaction. And then in earlier classes you have studied, or in your lower classes you have studied about elements and compounds, but no further classification of compounds, isn't it? You have studied about elements and compounds, but further classification you didn't study in your lower classes. But here we can classify compounds into further classification. Compounds can be further classified into acids, bases and salts. Compounds can be further classified into acids, bases and salts. Okay. Now we are discussing the different, first we are discussing about acids, that is concepts. There are different concepts of acids and bases. Various concepts have been given by different scientists, in order to regarding the definitions of acids and bases, and the three major concepts were the first one is Arrhenius concept. Arrhenius concepts of acids and bases. Then Bronsted-Lowry's concept of acids and bases, and the third one is Lewis concept of acids and bases. Arrhenius concepts of acids and bases, Bronsted-Lowry's concept of acids and bases, and Lewis concept of acids and bases. Here we are discussing Arrhenius concept and Bronsted-Lowry's concept and Lewis concept that you will study in higher classes. Okay. First we are discussing about the concept of acids and base according to Arrhenius. Arrhenius concept of acids, and according to Arrhenius, the substances which produces H plus ion in aqueous solutions or in water, they are called acids. So acids are the substances which produces H plus ions hydrogen ions in water or in aqueous solutions. We know what is aqueous solution. Aqueous solution means the solution that is prepared in water, that is called aqueous solutions. So, any substance which furnishes or which gives H plus ions in water or in aqueous solution, they are called acids. Example, a number of examples are there: HCl, H2SO4, then HBr, HNO3, H2, then phosphoric acid, acetic acid, CH3, COOH. A number of examples are there. All these acids, when they dissolve in water or when they mix with water, they give H plus ions. So, they are called acids according to Arrhenius. Arrhenius concept, acids are the substances which give H plus ion in its aqueous solutions. So, how they are giving H plus ion? We know, for example, let's take example hydrochloric acid. Hydrochloric acid, which on ionization, when we are splitting this into ions, it produces H plus Cl minus ion, isn't it? This dissociation is taking place in presence of water. So, we know when this react with that is this H plus ion react with the water, it forms H3O plus ions. Generally, we can represent like this, that is HCl plus H2O gives H3O plus Cl minus. This is the sum of these two reactions. So, I have splitted these reactions to, that is HCl, it forms H plus Cl minus, and this the hydrogen ion formed react with the water molecule and it forms hydronium ion. This is called hydronium ion, H3O plus, that is called hydronium ion. So, all these acids, that is sulfuric acid, hydrogen that is HBr, HNO3, acetic acid, all acids they furnishes H plus ion in its aqueous solution. They are called acids according to Arrhenius. Now, what are bases? According to Arrhenius, bases are the substances which give hydroxyl ion in its aqueous solution. Hydroxyl ions. So, what is bases? Bases are the substances which give OH minus ion. They are called hydroxyl ion. They give OH minus ion, that is called hydroxyl ion in its aqueous solution. So, when a base reacts with the water, it forms or it produces OH minus ion. They are called bases. There are a number of examples. I think you have studied a number of examples for the bases. We know sodium hydroxide is a base, ammonium hydroxide is a base, then potassium hydroxide, aluminum hydroxide. What is the formula of aluminum hydroxide? AlOH thrice. Then calcium hydroxide, CaOH twice. What is the this is called calcium hydroxide. All these are examples for bases, and these bases, for example, we take example sodium hydroxide. Sodium hydroxide, when it reacts with water, it gives Na plus OH minus ion. Na plus. This splitting is happening in presence of water. So, when a base is react with water, it produces OH minus ion. They are called bases as per the concept of Arrhenius. Okay. So, these are the Arrhenius concept of acids and bases. I hope you understood what is the definition, or what definition has given for acids and bases for as per according to Arrhenius. Arrhenius states that acids are the substances which give H plus ion in its aqueous solutions. Example, hydrochloric acid, sulfuric acid, nitric acid, citric acid, many acids are there. Then bases are the substances which give OH minus ion in its aqueous solution. You have to specify that word, aqueous solution. Only in presence of water they furnishes this OH minus ion, or in the case of acids, that is H plus ions. Okay. Now the second concept is Bronsted-Lowry's concept. Bronsted-Lowry's concept of acids and bases. So, according to Bronsted-Lowry, acids are the substances which are capable of giving hydrogen ion, that is H plus ion, when it reacts with other substances. So, when an acid reacts with other substances, they donate H plus ion with, to other substances. Or otherwise we can define as acids are proton donors. We know H plus ion is called a proton, isn't it? It is a proton. So, when an acid reacts with the other substances, these acids are having a capacity to donate H plus ion with the reacting substances. So, that is why they are called proton donors. Acids are proton donors. Example, H2O. H2O is an acid according to Bronsted-Lowry's concept. Then HCl, HNO3, H2SO4, then H3O plus ion, all these are examples for acids because they donate H plus ion or proton to the other substance, that is the substance which are reacting with the acids. So, that is why they are called proton donors. For example, when hydrochloric acid react with the water, when hydrochloric acid react with the water, so what happens, you know, this H plus ion, that is the H plus ion of acid given to, they transferred into, or it donates this H plus ion to water. So, what is happening here? H plus ion react with water and it forms H3O plus Cl minus. Here Cl minus. Here it is H plus and Cl minus. You know, this H plus ion react with the water and form H3O plus, and then H2O accept that proton and it forms H3O plus, then Cl minus ion. So, here since HCl is donating H plus ion to water, HCl is considered as acid according to, as per the concept of Bronsted-Lowry. And here water that accept the proton, that is called, this here water act as a base. So, what is the definition for base according to Bronsted-Lowry's concept? That is, bases are the substance which are capable of accepting a proton from other substances. They are called bases. So, bases are the substances which are capable of accepting a proton from other substances. So, we can call or we can define bases according to Bronsted-Lowry's concept. Bases are proton acceptors, isn't it? They are proton acceptors because they accept protons from the other substances. So, that's why they are called proton acceptors. For example, another example I will give you some. I will give you some examples for bases. NH4OH. What is NH4OH? That is ammonium hydroxide. It is a base. Then H2O. Even H2O also, what? It is a base. Then NO3 minus is a base. Cn minus is a base. How these are all become bases as per Bronsted-Lowry's concept? Let us see some example. See, for example, H2O plus NO3 minus. What is NO3 minus? That is nitrate ion, isn't it? Nitrate ion. Nitrate, not nitrite. N-I-T-R-A-T, that is nitrate. Okay. Though nitrate ion, when it reacts with water, so here which is the acid and which is the base? You can see here nitrate ion, when it reacts with water, it forms, see, one of the hydrogen HOH, that is water. One of the hydrogen ion, it reacts with the HNO, that is NO3 minus, and it forms HNO3, that is nitric acid, plus then what happens? What is next? Plus OH minus ion. So here water donate its H plus ion to NO3 minus ion. So here water act as an acid. It is water act as an acid. Here water act as a base. Here water act as an acid. And here NO3 minus ion, they accept one proton and hence it is a base. So why? Because it is a proton acceptor. So here this is the base. Now you can see here, here in this reaction water act as an acid and here water act as a base. These type of substances which are act as both acids and bases, they are called amphoteric substances. Amphoteric substances. The substances which act as an acid and base, both acid and base, they are called amphoteric substances. So these two concepts are given in this chapter. That is one more concept is, that is Lewis concept of acids and bases, that you will study in your +1 and +2 classes. Okay. So here two concepts we have discussed so far, that is Arrhenius concept and Bronsted-Lowry's concept of acids and bases. So what is Arrhenius concept of acids and bases? According to Arrhenius concept, acids are the substances which furnishes or which gives H plus ion in its aqueous solution. In its aqueous solution, that you have to highlight the point, in its aqueous solution. Only in presence of water they furnishes H plus ions. And then bases are the substances which furnishes or which gives OH minus ion in its aqueous solutions. That is according to Arrhenius concept. Then Bronsted-Lowry's concept. In Bronsted-Lowry's concept, acids are the substances which are capable of giving H plus ion to other substances, or acids are proton donors, or H plus ion means proton donors, and bases are the substances which are having the capacity to accept H plus ion, and that's why bases are proton acceptors. So I have given you some examples. So these are the concept of acids and bases according to Arrhenius and Bronsted-Lowry. I hope you understood this acids bases concept. Now next we are going to discuss Before that, one more term that we want to discuss, that is we heard about acids, that is strong acid and weak acid, strong base and weak base, isn't it? So, the concept of strong and weak acids and bases. Strong and weak acids and bases. So, what do you mean by strong acid? Strong acid means an acid that ionizes completely in water and it produces more amount of H plus ion, that is called a strong acid. Strong acid is an acid which ionizes. What do you mean by ionize? Ionization means what? They become ions, that is positive ions and negative ions. So, they ionizes completely and gives more amount of H plus ion in water, in aqueous solution. That is called a strong acid. That is called a strong acid. Strong acid example: HCl, H2SO4, HNO3. All these are strong acids because when they undergo ionization, they undergo complete ionization when it mixed with the water. Okay, Cl minus ion. H2SO4, it completely ionizes to give 2H plus plus SO4 2 minus ion. HNO3 gives H plus plus NO3 minus. So, they undergo complete dissociation, they undergo complete ionization when it reacts with water. So, that is called a strong acid. So, strong acids undergo complete ionization and gives a large amount of H plus ion, that is called a strong acid. Then what is a weak acid? That is strong acids. What is a weak acid? A weak acid is a substance which ionizes partially and give a lesser amount of H plus ions. So, weak acid. What do you mean weak acids? Weak acids are the substances which ionizes partially, only partial ionization is taking place or incomplete dissociation is taking place, and they furnishes or they give only small amount of H plus ion. That is called weak acids. Example: acetic acid, CH3COOH gives CH3COO minus plus H plus ion. Here you can see a double headed arrows. These double headed arrows represent, this is a reversible reaction, that is, it means this is called forward reaction and this is called backward reaction. So, in this reversible, both reaction is taking place simultaneously, that is why it is called reversible reaction. And here acetic acid, what is happening when on dissociation, it produces acetate ion and H plus ion, but complete dissociation is not taking place here, that is why it is called a weak acid. There are a number of examples are for this weak acid. You can see H2SO3, not SO4, SO3, that is called a sulfurous acid. It is also a weak acid. Sulfurous acid, it is also a weak acid. Then carbonic acid, H2CO3, carbonic acid. Lactic acid, all these are weak acids. Weak acids are the acids which dissociate partially or partial dissociation is taking place or partial ionization is taking place, and they give only lesser amount of H plus ion. They are called weak acids. So, what is strong acid? Strong acids are the substances, they ionizes completely and give more amount of H plus ion. They are called strong acids. Example, hydrochloric acid, sulfuric acid, nitric acid, etc. And then hydrobromic acid. All these are strong acids. Then weak acids. Weak acids are the substances which dissociate partially or which undergo partial ionization and they give lesser amount of H plus ions. Example, acetic acid, sulfurous acid, lactic acid, carbonic acid, all these are weak acids. Now, that is acids. Then what about bases? What about bases? What is a strong base? Strong base is a substance which dissociate completely and give more amount of hydroxyl ion, OH minus ion. That is called a strong base. A strong base is a substance which dissociate or which ionizes completely and give more amount of or more concentration of OH minus ion. They are called strong bases. Strong bases example, sodium hydroxide is a strong base, potassium hydroxide is a strong base, calcium hydroxide is a strong base. All these are strong bases because when they dissociate or when they ionizes, it gives large amount of hydroxyl ion. They undergo complete dissociation and also give more amount of OH minus ion, and that is why they are called strong bases. And weak bases, they dissociate partially. They dissociate partially and give lesser amount of OH minus ion. Lesser amount of OH minus ion. Example, NH4OH. What is this? Ammonium hydroxide. Ammonium hydroxide. Then magnesium hydroxide, aluminum hydroxide, zinc hydroxide, etc. All these are weak bases because they undergo partial dissociation and give lesser amount of hydroxyl ion. Okay, these are strong acids and bases, and strong acids, strong bases, weak acid and weak bases. I have given some examples for this: strong acid, weak acid, strong base and weak base. Now, one more term you have heard about the acid, that is concentrated acid. And dilute acid. Dilute acid or dilute base, concentrated acid or concentrated base. So, what do you mean by concentrated acid? It is very simple. Concentrated acid means, we know in a solution there will be a solute and solvent, isn't it? If the acid is more amount and only lesser amount of water is present, that is called concentrated acid. So, in a concentrated acid solution, the large amount will be acid and very few amount will be what? Water. So, that is called concentrated acid. And dilute acid means, in dilute acid majority is water and the small quantity will be what? Acid. That is called dilute acids. Okay. So, these are the general concepts of acids and bases, and strong acid, strong base, weak acid and weak base, concentrated acid and dilute acid. Okay. Now, next we are going to discuss about testing of acids and bases. Testing of acids and bases. We know we can test a chemical by simply tasting that substance, by tasting. If it is sour in taste, it is acid. If it is bitter in taste, it is a base. But if the substance is an unknown chemical, how can we test that? Because sometimes that chemical may be poisonous, isn't it? So in that cases, what we do? So we are using a substance which is used to identify whether the substance is acid or base. That substance is called indicators. That substance is known as indicators. So what are indicators? Indicators are the substances which are used to identify whether the given substance is acid or base, isn't it? And acid or base by changing its color or order. By changing its color or order, because this indicator may change its color or order if you are pouring some acid or base in it. Okay, that is called indicators. So indicators are the substance used to identify whether the substance is acid or base by changing its color or order or smell. Okay, that is called indicators. Generally, there are three types of indicators are there. First one is natural indicator. And second one is synthetic indicators. And the third one is olfactory indicators. Natural indicators, synthetic indicators and olfactory indicators. So here natural indicators are the indicators which are present in nature, that is they are obtained from plants that you have already studied in your lower classes, which are the natural indicators. The indicator, that is litmus solution, which is prepared from lichen plant. Lichen plants, we will get what? Litmus solution. Nowadays litmus papers are there. So litmus solution also there, and lichen plants we can prepare one such natural indicator. So lichen plant or litmus solution is a natural indicator. Then turmeric is a natural indicator, and then red cabbage leaves extract. Red cabbage leaves extract can be used as a natural indicator. And then flowers of hydrangea plant. Flowers of hydrangea plant, it is also a natural indicator. All these are natural indicators because they are obtained from plants. Now synthetic indicators. Synthetic indicators which are prepared artificially in the laboratory, and the most commonly used synthetic indicators are phenolphthalein, and methyl orange. Phenolphthalein and methyl orange, these two are the most commonly used synthetic indicators, phenolphthalein and methyl orange. Before going into the olfactory indicators, let us study the differences, how they differ in their acidic and basic medium. What differences they are showing these natural indicators and synthetic indicators, okay, that we will discuss now. So, here we have taken the indicators, natural indicators, that we have taken a litmus solution. Litmus solution, if it is the litmus solution, we know in its neutral stage the color of the solution is purple in color, purple color. And in, let us see what is the change in acidic solution, in acidic medium what is the change, and in basic medium what is the change. So, acidic medium, in its neutral stage its color is purple. In acidic medium what is the change? It become red. Litmus solution is red in acidic medium and blue in basic medium, isn't it? Litmus solution is red in acidic medium and basic medium it is blue in color. Then another, that is turmeric. Turmeric we know in its neutral solution it is yellow in color. So, it retains the color, turmeric retains its color, that is yellow in acidic solution. And what about in basic solution? It become a reddish color, it become reddish. Reddish color means, you know, when if any curry stains are there in any white clothes, any clothes. So, when we are washing with the soap solution, we can see that that color is changed into yellow colored stain, curry stain is changed into reddish color. Why? Because soap solution is a basic solution, that is why in basic solution yellow color changes into reddish color or red color, that is due to the presence of base. Since that medium, that soap solution is basic solution, it changes its color, isn't it? And we can again change that color into red, into yellow, if you are pouring some lemon, some lemon juice are pouring onto that cloth, again it changes into yellow color, because now at that time it changes into acidic medium. Even if it is acidic medium or neutral medium, that its color will be yellow. Okay. Then red cabbage leaves. Red cabbage leaves, that is it is blue in color. Sorry, it is red in color, red color. So, that is in neutral solution it is red color, in acidic solution also it is red color, and in basic medium it changes into green color. Okay, it changes into green color. Then flowers of hydrangea plant. Flowers of hydrangea plant, it is actually it is blue in color. In neutral solution it is blue in color, and in basic medium it is pink in color. It is pink in color. So, these are the color changes in the case of natural indicators. Litmus solution red in acidic medium, in basic medium it is blue in color. Turmeric it is yellow, and in basic medium it is reddish color. And red cabbage leaves, that is red in color in neutral medium or in acidic medium, but in basic medium it is green, and then blue and pink color. Okay. And one more topic, small topic, that is synthetic indicators. synthetic indicators. There are two synthetic indicators, mainly we are using phenolphthalein, phenolphthalein and methyl orange. Phenolphthalein in acidic medium, it is a colorless solution, and in basic medium it is pink in color. And methyl orange, in acidic medium it is red color, and in basic medium it is yellow color. Methyl orange, that is, it is acidic medium, it is red color, and basic medium yellow color. So these are the color changes happening in the case of synthetic indicators and natural indicators, and these synthetic indicators and natural indicators are otherwise known as visual indicators. Because they show the color difference in acidic and basic medium. Okay, so these are the indicators, that is natural indicators and synthetic indicators, and the next topic, that is olfactory indicators, that we will discuss in the next class. Okay, thank you.